So the second thing that we're going to do today is this is on 018B. We have already completed face-to-face this page of notes, 018B, page 1. We've already done page 2 on intercepts. We've already done page 3 on division, and we already did page 4 about the asymptotes. So you can go back and review that video if you need to. This is practicing the vertical and horizontal asymptotes. So I was just going to have you practice today doing those asymptotes. So I'm going to do a couple with you, and then I'd like you to try them by pausing the video and then unpause the video to check your answers. So can you remember how to find a vertical asymptote? It is where is the denominator equal to 0 each time. So where is x minus 9 equal to 0? I think you can see if I add 9 to the other side, it's when x equals 9. So the equation of the vertical asymptote is x equals 9. Let's do one more of the vertical asymptotes together. Where is this denominator going to be undefined? So where is x squared minus 9 going to equal 0? I'm going to do a little factoring. This is a difference of squares, x plus 3, x minus 3. So my two vertical asymptotes would be at -3 and +3. So pause the video, do the rest of the vertical asymptotes only, and then come back here to check your answers only on the vertical asymptotes. Then I'm going to do a couple of the horizontal asymptotes with you. All right, so you should have now done all the vertical asymptotes. Let's check our answers. This one should have been at x equals 8. This one I have to do a little factoring work. Let's see. If I set the denominator equal to 0, I would have to factor out x squared. And then I would have x minus 2 left for that greatest common factor factoring strategy. So my two asymptotes are at 0 and at 2. X equals 0 and 2. So you might have two vertical asymptotes. All right, I'm still doing vertical asymptotes here. So if you didn't do them, try these 4 vertical asymptotes before I show you the answer. All right, x squared plus 4. X squared plus 4 equals 0. I can't actually do, because if I try subtracting 4 to the other side, I can't take the square root of -4. There's no solution. So there's actually no vertical asymptotes. And on n, if x were 0, the denominator would be undefined. So x equals 0 is the vertical asymptote. On q of x, it would be at -1. And at t of x, it would be at 0. So hopefully you're getting better at finding the vertical asymptotes. So then remember, for horizontal or slant asymptotes, there's 3 separate rules. If the numerator is higher by 1 degree, we're going to do division. If the denominator is higher, then the asymptote is at y equals 0. If the powers are equal, the horizontal asymptote will be the ratio of the coefficients. So let's find one of each of those examples. All right, so I'm going to look for a case when the numerator is higher first. No, here we go. Numerator is higher, right? So I need to do division. X minus 8 going into, let's see, x squared. So I do x times x is x squared. X times -8 is -8x. So what does this box have to be? This has to be positive 6x. So I need to add 14x so that 14 minus 8 gives me 6. So 14 must be the rest of my asymptote. Y equals x plus 14 is the answer for the asymptote. If you wanted to go further for division, you'd have to do 14 times -8, which is -112. Then you'd have to find the remainder to get you to 5, which would be positive 117. The remainder just shows you that, hey, there is an asymptote, but you only need the equation of the asymptote. So we found one of those examples. What about the denominator is a higher power? How about example G? X squared is on the bottom, which is a higher power than a linear function. So this will just be y equals 0. The denominator is going to get really, really big faster than the numerator. A little number divided by a really big number, like a little number like 9 divided by a big number like 9 million is, this is scientific notation, 0.000001. All right, and the last situation, what if the powers are equal? That's the case in this first problem, right? I have x to the first and x to the first. I need to strip the coefficients of x. In this case, the coefficients of x are 1 over 1, which is 1. So I have a horizontal asymptote at y equals 1. So I've done one of each of those examples. So I'd like you to pause the video and try j of x and then the back 4 problems. So I'm going to do j of x right now, and you're going to send me the back 4 problems when you've completed them. You could look at a graphing calculator too if you need help to find these out. So let's see, on this one, the denominator is bigger. So when the denominator is bigger, the asymptote is y equals 0. So now you are going to complete these 4 last problems and send me this back page in Google Classroom. Thanks.